All right, welcome to a great program, freely downloadable for only 5 nodes. It is called Hydrocad. Similar programs and things exist in Civil 3D, but this piece of software is as intuitive as any. Not quite SketchUp, but pretty good. And my favorite part is to watch students struggle here with how to begin or create a new project. So I'll let you kind of look at the screen here, see if you can figure it out. As you're looking at the screen, remember that the key constituents we'll be looking at in terms of a stormwater modeling system, which is based on links and nodes as a system, is going to be a subcatchment or a drainage area which generates flow. Potentially a reach which carries flow, but we're going to not use that as is recommended by the program. We're just going to use a pond. A pond which captures and perhaps either stores flow or stores and releases flow or just releases flow. And a link which is then used to combine projects to projects, realizing that this program Hydrocad allows you to only use 5 nodes, and a typical city would have at least a node for every catch basin or manhole, and quite a number more than that potentially. So remember that we have a subcatchment, which is the same as a drainage area or a drainage basin, which generates flow based on an area of the country, some proposed or some historical data on rainfall, how likely the storm is. A storm that is called a 100-year storm would have a 1% chance of probability of occurring in any year. A 25-year storm has a 4% chance of occurring in any one year. A 10-year storm has a 10% chance of occurring in any one year. Around here, central Wisconsin and many parts of the state, a 4.2 inches in a 24-hour period is considered a 10-year storm. 6 or 6.2 inches in a 24-hour period is considered a 100-year storm. A 25-year storm is 4.8 inches. And these numbers actually tend to slide up as we're looking at much more dynamic, a more dynamic rainfall pattern with around the state and around the country to that regard. All right, so you've seen it. How do you think you open and create a project? You just click here, and it's just beautiful. All right, so you're going to give it, typically you're going to tie these project names into some names that would be on a plan set. Maybe it would be Inlet 5, or it might be Drainage Basin 4, or it might be station or it might be the road name. So I'm just going to call this Northeast Road for my project name, and that's going to bring it up to a point here where I have a blank screen. Pretty straightforward. We'll see later that setting the settings up here in terms of units and the like is going to become important. But basically, these settings will emerge as you try to do a calculation, and they have to do with what is the rainfall pattern. We will see that pretty much a type 2 storm from your readings, which more or less compresses about 80% of the rainfall into the middle 2 hours of the storm, I think it is, or a very compressed portion. So it kind of sounds like this. If you think about the rainfall over a 24-hour period, so what you've got then is basically intense rainfall that around our state, if we look at in a 100-year storm, even though the intensity or the total rainfall in a 100-year storm is about 6 or 6.2 inches, that middle intensity is about 9 inches per hour. And so it's really that rain coming very quickly that for which we have to design a number of systems, particularly our gutters and a number of other things like that. We have, as you get farther and farther down, the drainage basin, you have something called flow attenuation, which takes out some of those peaks. So remembering that for the CIA formula, which is one of the formulas, good basic formulas, the intensity there is going to be at around 9 inches per hour in a 100-year storm, and I think it's about 9 inches per hour, and we'll review that in class. But basically that we have to know that your settings are set, the storm information that you're using is based on the geography of where you live and the history of the rainfall patterns there. All that said, you pretty easily go about defining a subcatchment or basement by left-clicking and dragging it onto your page right away right clicking and editing and giving it a name. So I might say this is Northeast Road sag, and I'm just going to do the sag here. In other words, the very bottom of the roadway where in effect the water might have blown by because of leaves or bags or whatever else, every other inlet that was up the road. As you look at inlet design, a lot of inlet design is about keeping water off the road and getting it into pipes down below, but we must remember that all drainage systems must be designed so that if the pipes fail, the road still can serve as the major drainage area, the major drainage conveyance structure. In other words, the road becomes the river to protect the property. Every drainage basin is going to have an area. The thing to note here is that if you click the large areas off, you are dealing in square feet. If you click the large areas on, you're dealing in acres. I'm just going to do a 1 acre, but of course you know there, I'm clicking there, I'm going to go 43,560, that's square feet. A drainage basin is described by 3 things: an area, a curve number which describes the imperviousness of the, or how impervious the area is, and you can look that up. A high number is 98, a low number would be somewhere around 52 or thereabouts, 58 for a meadow, and we'll talk about soil conditions and how that's described, but I'm doing just the basic 1 acre parking lot here, which we'll see how it comes out. So I have the time of concentration, or the curve number there, the area, the curve number, and the time of concentration, which describes the number of minutes it takes for a theoretical raindrop to go from hitting the farthest point in the basin to where it's more or less exiting, or your point of interest in the basin. We never use less than 5 minutes. There's all kinds of different ways to put that in. One way will be direct entry. We'll just start with that. So we'll do it the 5 minutes. So we hit OK here. We now have described that entire basin. We hit apply. We've done that entire basin. And how you can check it then, and whether things are kind of defined here, you can hit a right click and you can do a node report. And it gives you an error, the rainfall not specified. Alright, so that says, okay, where do I specify it? I specify it up here in calculations. And in the rainfall, generally we will be using the SCS TR20 method, using these kind of standard storage indication and transportation method routing. There's all kinds of different ones to use. And pound routing is going to be store in for now. Rainfall, type 2 rainfall is what we want to use. In this area of the state, we put the depths of something like I said, 4.2 is a 10-year storm. Duration is 24 inches. And then we tend to give this a name, 10-YR. Hopefully it remembers it, because if we save it here, it will then, we won't have to reapply it each time. So I can hit save. That remembers the 10-year storm. And I could basically put 4.8 here and call that the 25-YR storm. Save, and I could put 6 here, 6.0, and that's some of the basic ones, the 3 big ones, and there's a couple more down below that, -YR. So I've saved each of those. I'm going to apply, hit OK, which means now when I go right click, node report, it gives me a report like that. And we see for our memory that a 100-year storm, if you see that there, on a 1 acre parking lot generates at about 9 CFS. Let's try it again this time. Set that to 10-year. Right click, node report, and we notice that a 10-year generates 6 CFS. But the other number to start getting in your head is that it also generates a total volume of runoff. And the easiest one to remember, I would say, is the one for the 100-year storm. We'll go back and click on that one. Right click. And a 100-year storm that has about 6 inches of rainfall falling on it is about a ½ an acre foot. Right? Because you do have, actually in this case, a rainfall depth is greater than 5.27 inches. We gave it a rainfall depth of 6 inches. It does lose some to evapotranspiration and evaporation, but that's the introduction to the defining a quick drainage area. Thanks for listening. This is the first of the Hydrocad introductions. I'm going to save it and move on to the pond.